we looked at some organic compounds, specifically some hydrocarbons, and you saw the picture of the hydrocarbon, and then you wrote the name of the hydrocarbon. This time what we're going to do is I'm going to give you the name, and I'm going to ask you to draw for me the picture of it, the Lewis structure. So let's go ahead and let's take a look at some examples of how to do that. Let's say this is the name of the compound that I'm trying to draw. Let's take apart the name and figure out what the compound should look like. Okay? Remember some different parts that are in the name. Prefix tells me how many carbons there are. Penta, if you remember, if you look at the organic prefixes, means that there are 5 carbons in there. Di tells me how many multiple bonds there are, right? So di is a prefix that means 2, so there are 2 multiple bonds. But that doesn't tell me if they're double bonds or triple bonds. The suffix tells me that, right? So YNE tells me it's an alkyne, which means it's got triple bonds. So here is a compound with 5 carbons that has 2 triple bonds, and those triple bonds are on bond numbers 1 and 3. So let's start, in order to draw this, let's start by drawing a chain of 5 carbons. Okay, 5 carbons. And then let's find where the triple bonds are. They're on bond numbers 1 and 3. So let me number. I could number this way. 1, 2, 3, 4. Or I can number this way. 1, 2, 3, 4. And it doesn't matter which way I do it. Either way is correct. So I'm going to choose which way I want to number it. I'm just going to kind of number it this way. A little bit more intuitive for how we think, right? Okay, so my triple bonds are on numbers 1 and 3. So there's a triple bond right here, and there's a triple bond right here. Okay. Now, we've taken all the information out of there and we've put it here, but there's still something left that we have to do. We have all the carbons set up. We have the bonds right, but this is a hydrocarbon. There are also hydrogens. Okay? What we have to keep in mind is that each carbon should have 4 bonds around it. So let's go and let's look at each one of the carbons and make sure it's got 4 bonds around it. If it doesn't, we'll fill up those bonds with hydrogens. Okay. So looking at this carbon has 3 bonds right here, which means it needs 1 more. So I'm going to put a hydrogen right here. And now this carbon has 4 bonds. This carbon has 1, 2, 3, 4 bonds. So this carbon is good. This carbon has 1, 2, 3, 4 bonds. So this carbon is good. This carbon has 1, 2, 3, 4 bonds. So this carbon is good. And this carbon down here at the end only has 1 bond. So it needs 3 more. So I'm going to put 3 more hydrogens. 1, 2, 3. And there it is. There is 1, 3 pentadiene. Okay. Now, could you have possibly drawn this so that it looks somewhat differently? You could have, yeah. You could have drawn it more vertically instead of horizontally. You could have done that. You could have put a bend in that carbon chain. You could have done that. So, just because this is how I drew it, doesn't necessarily mean it's how you're gonna draw it. I mean, it should be correct in all the different ways that we just talked about, but our answers might look different, if that makes sense. So just because what you drew doesn't look exactly the same as what I drew, doesn't mean it's wrong, as long as it's got all those features in there that we talked about, right? Okay, up here I have drawn pentane, right? You notice it's an alkane, it's got only single bonds, it's got 5 carbons, so this would be called pentane. A lot of times when we draw these structures, we won't draw them like this. There's another way that we draw them. It's a little bit faster, sort of a shorthand way to draw this. We call it a skeletal structure because it looks a little bit like a skeleton. It's like stripped down to the bare bones. Okay, what a skeletal structure is we'll draw a line indicating the bond between carbon atoms. So here is this bond, okay? And it's understood and assumed that there's a carbon atom at each end of that line. Okay. Now we're going to draw the next bond between carbon atoms, starting at this carbon atom. Remember, we understand there's a carbon atom right here at the end of this line. So now we're going to draw this bond, but we're going to make it in like a slightly different direction. We just can't keep going straight because it'll look like a single line. So I'm going to have it come down this way. So this bond is here, this bond is here. Now we'll put this bond and then the next bond. So if you look at what I've drawn here, understanding there's a carbon atom at the end of each line, there's 1, 2, 3, 4, 5 carbon atoms. Okay. If one of them were, say, a double bond, let's say this were a double bond, and then I would have 1 pentene. What I would do is I would make that line a double line. It's hard to see on the video. See if I can make it a little bit better on the video. That's better. Okay, so we would draw like this, and that would tell us that this bond right here was a double bond, right? A triple bond, you draw a triple line, right? So kind of stripped down to its bare elements, that's a skeletal structure. So some of them are going to ask you to both draw the Lewis structure and the skeletal structure. Let's take a look at one of those. How about 2-butene? Let's draw the Lewis structure and then we'll draw the skeletal structure. Okay, so ene tells me this is an alkene. It's got double bonds, and that double bond should be on bond number 2. And but tells me that's the organic prefix for 4. So I have 4 carbon atoms. Let's draw that. 3, 4, with a double bond on bond number 2. So we could have 1, 2, 3, or we could have 1, 2, 3. Either way, this is bond number 2. So this one should be a double bond. Now let's go through and let's make sure that all of our carbons have 4 bonds and filling in hydrogens wherever we don't have 4 bonds. So this carbon only has 1 bond. So I'm going to add a hydrogen, and a hydrogen to make it 4. This one has 3 bonds. Here's 1, 2, 3. So this carbon needs 1 more hydrogen. This one's in the same situation. It's got 1, 2, 3. So we need 1 more hydrogen. I'll put this one on top and this one on the bottom just to kind of make it ease. I mean, they don't have to go on one side or the other in any particular way. This carbon only has 1 bond, so let's fill it up with 3 more hydrogens. Okay, so there's the Lewis structure. Let's draw the skeletal structure now. Okay, so I'm going to need 1, 2, 3 different lines, and the middle one needs to be a double one. So 1, 2, 3, and the middle one needs to be a double line. Okay. So there's the skeletal structure for this one here. Like we said a minute ago, might not look exactly the same as mine. You might choose to draw this 1, 2, 3, and make this a double line. These two are the same thing, right? The angles that they meet at don't mean anything, right? It's just the number of lines, indicates the number of bonds, the number of ends is the number of carbon atoms, and it shows you where there's a double or a triple bond, right? So either one of these would be an acceptable answer for that. One last thing to notice about skeletal structures I forgot to point out when I was talking about it earlier. In the skeletal structures, the hydrogens are not shown at all. Right? We understand there's carbons at the end of each line, but we don't even write the hydrogens at all. The thing about it is we're all smart enough to take this and translate it back to this, right? And put the hydrogens where they would need to be, right? So the skeletal structure does not show the hydrogen atoms at all. So there is a little bit about drawing the Lewis structures and the skeletal structures for some of these simple hydrocarbons that we've been looking at. Next time what we're going to do is we're going to look at branched hydrocarbons. So still just carbon and hydrogen, but with branches. And we'll learn about how to write the names for the branches and name those compounds. So until then, take it easy.